Hello everyone, myself Harish Kumar. I am going to present a research article. The title is The Water Chemistry and Estimation of Local Geochemical Background Values of Elements in Headwater Streams of Ken-Betwa catchment of Yamuna River, India. This is the content of the research articles we have prepared. First of all, we will discuss about the abstract. We have prepared the graphical abstract and the geological setup, and then material and method, what we have used, the methods, and then we will discuss the results and discussions, and then after we will discuss the conclusions. This is about the introductions or abstracts. This is the graphical abstracts. What we have prepared during our studies, we have collected and the make the this slide, and in which we have shown this is, we can see this is the water basin and catchment areas, and this is the our study area, and this is the photographs what we have collected the stream waters, and this is uh, the sections we have prepared, and I wanted to show that this is the flatland, and around this the granite terrain is present, and so we have shown here, and we have this agricultural lands, and in which the we have shown the sources of the solutes coming from the nearby the granitoid complex and granitic terrain, and this is the interpretations part, in which the Gibbs diagrams here, and this is the pipette diagram, and the rock water interactions figures, and this is the final product, that means the spatial dispersion map of hydrochemical solutes, and also uh, the elements, and one by one discuss in the next slide. This is the geological setup. The geological setup, this is the geological map of the Uttar Pradesh. This is the site we have marked in the red triangle, and is the water basins we have in the inset we have shown, and pink color, this is the granite complex. I mean, this is the hard rocks. The hard rock is very less here, and all the total is alluvium present here, the endogangetic alluvium, and this yellow, the pale yellow part is the it's called the Banda alluvium, and details in the next slide. This is the detail of the geological map. This is yellow part. This is the yellow part we can see. This is the alluvium, that means the Banda alluvium, and we can see the stratigraphy, the quaternary alluvium, and present here quaternary, and early middle to Pleistocene, middle to late Pleistocenes, and this is the drainage. Drainage means the major river, Yamuna major river, and this is the tributary. The Ken river is the tributary of Yamuna river, and Betwa rivers. It is also the tributary of the Yamuna rivers, and this is the landforms, active channels, and along the rivers we have the badlands topography, and this is the point bar paleo channels we can see here, and next slide please. This is the material method what we have used. The material we will discuss. First of all, the study area. The area is located in the Yamuna Ganga interflow zone, and it is a part of the upper Ganga plain. In the figure we will discuss in next slide. The figure, the region is the part of the alluvial watersheds of the Betwa and Ken sub-basin of Yamuna river. Elevation is vary from about 80 meters to, it goes up to the 300 meter to 400 meters, and northwest southwest of the landscape. The Yamuna, Betwa and Ken rivers as well as their tributaries are the major water sources in the regions north and flows southwest in the drain area. Then coming to the collection of water sample and its analysis. A total 23 number of water samples, stream water samples, we have collected using Survey of India topo sheet on 1:50,000 scale. Water sampling was done by the standard norms adopted by the American Public Health Association AFA 2005, and in order to determine the true elemental concentration and prevent contaminated samples, the samples were taken from the freshwater lower order streams or headwater streams. Samples that had not been impacted by industrial mining activity or samples from relatively pristine areas, neat and clean areas. And to minimize the effect of the seasonal and climatic variables, we have taken the samples in October 2021. Post monsoon, after post monsoon. And what then come to the methodology? What we have used the methodology in the current study. The methodology has been used by the suggested recommended by previous workers by Galaska 2007 and Galaska and Nigajewski 2011. They suggested that the geochemical background values can be determined using three methods. They have suggested three methods: direct method, that is called the geochemical method; indirect method, that is called the statistical method; and combination of both, that is called integrated. In the current study, we have used the integrated techniques that used both methods to evaluate the geochemical background values. For that, we have calculated the descriptive statics, mean, maximum, minimum, median, and standard deductions were calculated using the MS Excel tool to determine the local background values. Then we have used the statistical part using a whisker box plot in which the extreme or outliers from the individual samples were removed and remaining samples were used to get the background values. These values were compared with the standard set by Bureau of Indian Standards 2012 and WHO, international regulatory agencies. These are the methodology that we have used for finding out the background values. And coming to the next, the statistical analysis. We have discussed the the box plots. Already discussed this box plot, and box plots for the hydrochemical solutes and sediments which reflect the trend and statistical variance. We will show in next figure. A wider box shows the greater variability in the area, whereas the narrow box indicates the higher consistency. Longer whiskers imply a more diverse range of the values in the dataset. The dataset in the box plot depicts central tendency, median, skews, outliers, variability, dispersion, and distributions. Outliers represented by circles beyond the whisker indicate uncommon or anomalous concentration in the water sample. That these outliers we have eliminated from the data set to estimate the background values. This is the final product of the background values what we have calculated. Background values determination in the study, the Romano et al. and Liniana et al. 2019 used these techniques, yes, as suggested by Galaska and Majewski, for determining the background values. They excluded anthropogenically influenced samples from the analytical datasets because a large number of samples in the analytical dataset had concentration that were too high. So they were excluded these high outliers. The current study calculated the local background values using the similar integrated techniques. These descriptive statics, the minimum, maximum, mean, median, and standard deductions were computed using the statistical software. After removing the outliers from the whisker plots, the mean plus 2 standard deviation was used to estimate the local background values of the remaining datasets. These are the background values what we have proposed for the current study. This is the figure. This is the study area and stream water sampling sites. We can see in the inset, this is the catchment area of the Yamuna basin. There are different catchments and different shadeds, and this is the area marked. This is our study area, and this is our Indian continents, and the area is marked here. Is the brown. This is our state, Uttar Pradesh, and then again it is here is the triangle marked the study area. This is the 23 samples where I have plotted in triangle S1, S2, SW3, SW4 like that, SW22 and SW23 like that. 23 samples were plotted in drainage. These are the Yamuna rivers, and this is the tributaries, the Ken river, Betwa river. This is the Betwa river. This is the Ken river. The tributaries of the Yamuna rivers. These are the different nalas, the small drainage, where, and in the inset, this is the elevation map where we can see this is the Yamuna river, the white shade color. This is the lowest level, I mean up to 100 meters, the white elevations, and here this sky blue and green part is 300 to 400 meter elevations, and gradually it decrease the brown, light brown, then light blue, and 200 to 100, then 80 meters, then like that. This gradually decreasing toward white watershed where the Yamuna river is going to northeast and eastern part, and this is the tributaries where we can see the hillocks where the 3 to 400 meters the granite terrain where we have the next slide is this is about the list of the elements what we have analyzed, and we have divided according to their the convenience to analytical this is the spot analysis, temperature, pH, specific conductivity, dissolved oxygen, salinity. These physical parameters we have analyzed with chemist on the spot, and then we can see the package A. These are the anions, cations, and these are the analyzed by the chemist by the different techniques, titration method. They have used. He has used the titration method for the analysis, and the package B. These are the elements and REs. These are elements and REs and analyzed by ICP-MS in the lab. And in package C, the fluoride, boron, and mercury is are also analyzed in the lab. Uh, this is the photographs of the our team, and this he is the chemist, our geologist, and our myself. And this is the stream. This is the flowing stream where the we have collected the water samples, stream water samples, and this is also a photographs, field photographs, where the chemist uh, is collecting the waters, and this is the portable water analysis kit called Systonic Portable Water Analysis. The chemist uh, use this portable water kit for the analyzing the spot analysis. A spot analysis, I mean parameters, physical parameters, pH, salinity, temperatures, and other hydrochemical solutes. And then we have results and discussions. In this sections, we will cover the general stream water chemistry, water quality, and background values of the main ionic and cationic solutes, trend and statistical variation of the major solutes and elements, water quality and background values of the trace elements, spatial contour map, and source of the elevated aluminum and iron. Then we have prepared the correlation coefficient and hydrochemical classification of water by using the pipette diagram and Gibbs diagram. Also, we have prepared to know the source of the hydrochemical ionic solutes, and we have discussed about the public health implication, if any. Uh, this is the slides regarding the analysis of the physical parameters, what we have tested, what we have analyzed. This is the PS, TDS, specific conductivity, temperature, DO, and this is anions, bicarbonate, chloride, chlorine, nitrate, phosphate, fluoride, and this is the sulfate, sodium, potassium, calcium, magnesium, and these are the solutes. Number of samples, total number of us 23, and 21, 23. Why is 23 and 21 and 18? Because these are the eliminated outliers, number of samples. That's why here 18 and 21 we have eliminated. We have uh, the outliers. So this is given these numbers 20, 21, 22, and DL is the detection limit. There is no detection limits in this physical parameters, and we have nitrate detection limit, phosphate, some fluoride, and sulfate, and also sodium, potassium. These are the detection limit, and this is the minimum, maximum, mean, median, standard deviations, and coefficient variation. And this is the red color. We have marked the background values, what we have calculated using the statistical software. And mean plus 2SD, mean plus 2SD, and these are the regulatory agencies, BIS, Bureau of Indian Standard, and they have fixed. These are the limitations, and alternate sources, if not available, we can use the range. These are given the range, and acceptable and permissible limit. We can say acceptable or permissible limit, what we have compared. And WHO, we have also used the WHO guidelines. These are the, I think, same guidelines here as in the Bureau of Indian Standards. And this is about the hydrochemical solutes. And next is the elements and REs. These are the statistical description of the elements and calculated background values of the water samples. And after outlier removal from the analytical data sets, we are getting this one 22, 21, 23, 21, like that. And these are the descriptive statistical component detection limit, minimum, maximum, mean, median, SD, and we have calculated the BG values for the elements. And in the red color, we can see there is uh, there is only two elements, aluminium and iron. We can see it is more than permissible limit. Here the permissible limit is for the aluminium is fixed 0.3 to 0.2, but we are getting the higher values 672 BG values, and it goes up to the maximum 4303, and the mean is the 366, and iron is the 420. It is also the higher values. It's the more and more higher values. It's the 0.3. We can see here. And other elements we are getting within the permissible limit of the PIS and WHO. This and then come to the uh, uh, table 1, the continued part. There is also elements and REs, lanthanum to lithium. These are the REs, 14 REs, where we are getting the very low concentrations, and because we have collected the stream water from the pristine areas, I mean the not affected by the human activities or anthropogenic any activities, we have not seen, we have collected neat and clean waters, so we are getting there is no with no higher values from the elements or ice. And next, the this is the statistical plots, I mean box pixel plot, where we can see the hydrochemical solids of the pH, EC, TDS, TH, and sodium, potassium, calcium, and other anions. We can see the plottings. The outliers, where we can see the outliers, there is a EC, the two outliers are more than 100, more than 1000. But EC is the permissible, within the permissible limit. All are the within the permissible limit. There is no harm. Red dotted line is the, these are the regulatory lines where we have plotted here. WH1 BIS we can see here. So there is all are the within the permissible limit. All the solutes. This is box plots of the elements and REs. We can see here the all are box plots are given the trends. We can see here the aluminum in the second parts, the outliers. These are outliers goes up to 1000, above 1000, and something it goes up to the 4000 here, logarithmic scale. We can see here. So these two outliers we have eliminated and calculated the background values. This like that we have calculated other background values where we can see the outliers. There is not much more affected the elements by the anthropogenic activities. So these are the box plots. And finally, we have prepared the spatial contour map. Spatial contour map, spatial dispersion of the elements of the hydrochemical solutes, where we can see the pattern. These are the red color. These are the red colors in all the sample site we are getting the sample sites 22. These are for the aluminum. We can see 22 here near the Yamuna river. 22 sampling site 22. This one, there, and here, and here, and here. And twos are the iron. Sampling site 17. These are two sites are the higher concentration of the iron. Because the aluminium, why the aluminium is higher? Because the nearby is the we have the granitic terrain, so that solutes are come, and that elements the uh, come from nearby granitic terrain, the felsic mineral. So we are getting the aluminium and irons. Irons we can getting more because the iron can uh, only come from the anthropogenic activities or something like that. So these are the plottings of the selected hydrochemicals or elements. We have taken only aluminum and irons because they are higher values. So we have, this is the aluminum plots and this is the iron plots. So we wanted to show that's why look like that. So next slide is we have the Gibbs diagram. We have plotted the all 23 samples, and we can see here is the all the samples are towards rock dominance. That means the rock dominance, that means the near about the felsic granitic terrain is present. So there is no evaporite, no precipitation dominance, because only the uh, uh, felsic rocky terrain is present, a granitic terrain nearby. So we are getting these are the rock dominance, and similarly in this also the rock dominance, because there is no carbonate, there is no any other limestone, carbonate rocks, etc. So there is we are not getting the plots. We can see these are the and these are the bivariate scattered plots in which the normalized sodiums and bicarbonate. We can see the all the samples 23 samples fall into the silicate rock weathering. That means all the like that Gibbs diagram, the water interactions, it is here we can see the clustering of the all samples. I mean 99 samples, 99% of the samples uh, fall in the silicate rock featherings, and no carbonate, because there is no carbonate rocks are present here, so we are not getting the carbonate dissolutions from any samples. And here also silicate rock weathering, we can see all the samples are from silicate rock weatherings. Like that, the scatter plots between the calcium magnesium versus bicarbonate, we can see the clustering of the samples here and the dolomitic dissolutions lines, and we can see here also like that calcium. And this is the pipette diagram. We have plotted all the samples, 23 samples. We can see these water types, water which the hydrochemical hydro types of the water. We are getting the calcium, magnesium, chlorine, sulfate type of the waters. These are the clustering. We can see the calcium, magnesium here in the diamond plots. We can see, and sulfate here, this triangle. So the sulfate type and chlorine types, and we have also prepared the correlation coefficient of the hydrochemical solutes or variables along with aluminium and iron. Of we can see the pink is the very strongly correlated, and strongly correlated 0.65 to 0.85. These pink are correlated with the, so we have the correlation matrix. We can uh, calculate the correlations between the two variables. And finally, this is the conclusion part. The conclusion part, the analysis shows that the catchment lithology of the area primarily controls the concentration levels of all these major ions and elements. Primarily control the catchment areas. Now, all the water samples contain pH levels indicating that stream water is slightly alkaline. However, this may be fluctuate with the seasonal and temporal variations. All the elements are within the globally accepted legal regulatory limits except aluminium and iron. Significant level of the aluminium and iron have been identified, indicating potential health risks to humans and aquatic life. Water quality data shows that high concentration of the aluminium is caused by the intense weathering of the felsic rocks, BGC, Bundelkhand Granitic Complex, that means granitic terrain in the vicinity, and it is interpreted as a geologic or natural sources, not anthropogenic. Elevated iron is the most likely induced by the combination of the causes, maybe including the local land use, bacterial decomposition of the organic matter, deep weathering of bed-lying soils, and leaching runoff during the rainy seasons. And regarding heavy metals and metal oils, we have arsenic, chromium, cadmium, lead, nickel, mercury, zinc, copper, and manganese. These are found in the trace amounts or below the detected limits. There is no harms and pose no risk to environment or human health. Dissolved REs levels in the water samples are relatively low, indicating a geogenic source. So it is we have suggested or recommended that water analysis should be conducted regularly to the protect stream water resources, where particularly in the communities that they really slowly on the stream water resources. They really depend upon the stream water resources, and collection of more water samples in both the pre and post monsoon period to track the rate of the variation, particularly iron and aluminum concentration about current background values. And the outcomes of these geochemical analysis are significant and provide the robustest framework for assessing the public and aquatic ecosystem health and designing effective environmental management strategies. This study can be used to evaluate the how industrial discharge, agriculture runoff, and urban growth affect the water quality. Understanding local background, concentration, and baseline levels will help to detect and fix the human caused changes. So this is all about the our research work regarding the concentrations in the stream waters, and the background values we have fixed for the futures use. And now come to the acknowledgements. We thanks to the science father, and we also thanks to the organizing committee. The authors are grateful to the additional director general and head of the department, Geological Survey of India, Northern Region, and the Deputy Director General, State Unit, Uttar Pradesh, for providing the logistic support for the fieldwork. We also thank the officials of the Chemical Lab, GSI, Northern Region, for the chemical analysis. We extend our gratitude to Dr. Kuldeep Prakash, Professor, Department of Geology, Banaras, Hindu University, Banaras, for the guidance and support. I am also thankful to Sri Javed Ahmed and Sri Shivad Naik, geologist, GSI Northern Region, for their support in processing the investigated data and completing the statistical analysis. So, thank you, thank you, thank you so much.